comments and ask questions, you have something to add. And I really like, for those of you that were in Tim's presentation this morning, I really like this idea of open source guitar building. And, you know, everything he had is open source, and everything, there's a chair here, somebody can use that. Everything here is open source. When we're through, usually most people are interested in adjustable playing action. If you have an interest in adjustable playing action, if you'll sign up with an email address, I'm not selling it to anybody. I'll just email you everything I have about parts lists and that kind of thing on how to do it. Because to me, it's we'll get into it. Makes a lot of sense. Okay, who knows something about Windows? Oh wait, maybe I got it. Okay. My name's Chris Jenkins. I don't even remember what they said the title of the talk was. Somebody got the program, read it.
Guitar construction techniques to maintain instrument playability over time.
Yeah, and every one of these techniques is that. But to me, the beauty of it is that I think that every one of these things we're going to talk about will also enhance this. There's a chair there, a chair here, or back. Okay. Some in the back. Enhance the sound quality also. So that's a real win-win when you can do both. My son and I build lame horse guitars in Texas. He lives in Austin, and I live in a little town called Mansfield, which is the Dallas-Fort Worth area, about 200 miles apart. And we ship parts back and forth FedEx. You know, it's one day and $10. But as those of you out there that have sons, probably, especially some you tried to work with, we work best together 200 miles apart. It works out real well. We get together every once in a while, and then it's really good. But you know, if it was every day, it probably
15 minutes.
And I said we're in Texas. I just put this in there because this is a guitar. A guy sent me this guitar back for a repair, and I heard something shaking around in it, and I shook that into the sound of. This guy's a cowboy singer and lives down around San Antonio, you know, where they've got more rattlesnakes than cats. And he put that in there and said, "Oh yeah, man, makes it sound a lot better." So it scares the hell out of repair guys. So first we're going to talk about access panels. There's the seats at the back, I think. I think I asked this a minute ago, but has anybody here ever made an access panel, put one in their guitar intentionally? So, well, you know, I'm not really a repair guy, but I think I can probably speak for you. When you see something like this, it's going to make your job a lot easier, right? So why do it? We're talking about longevity here, and this is the one thing we're going to talk about that has no effect on sound quality whatsoever, good or bad. But if you're working inside that guitar, you need to inspect the inside of that guitar. It's a godsend, because you can get in there to your elbow, move around freely. You can inspect everything easily. It's a great thing.
Even set a jack in place.
Exactly. Anything else. And this is just after one's being cut, you know, gives you an idea what you can view in there, you know, as you're looking at the guitar. there's nothing you don't have access to.
Does this,
Now, there's a downside, people can see what you did in there very easily. So, maybe that helps your sound quality, helps the quality of your build, because people are gonna be inspecting it.
does that compromise the end block?
No, I'll show you in a minute. It's a big M block, but it's very light, and you'll see it. No, I think probably as far as stiffening up the sides and structurally, it's better, actually. This is what I make the M block out of. It's bendable plywood. It's plywood you can get that's made to wrap around, round things like spiral staircases and things like that. And so I take a couple of 3/8 inch pieces of that and glue them up. First I just glue the blocks in the mold with the sides in there, so get a perfect fit, pretty much perfect fit.
Is that curved on one side, the plywood? Is it curved? On
No,
one side, okay.
it just,
It's flexible enough to,
what they do is lay all the layers up in the same direction, and it really bends. And you can buy it either way. If you get a 4x8 sheet, you can buy it that bends along the 8-foot side or bends along the 4-foot side, whatever you prefer.
That epoxy that you're using?
Yeah, it's epoxy, thickened epoxy, using this, it's West Systems with the silica added. I'm not proposing anybody does poor work. We want to make everything fit as good as possible, but, if you're using that thickened epoxy, it doesn't have to fit perfectly, like if you're using hide glue or if you're using tight bond or whatever. Come on in, guys.
What does your plywood cost you in order to source it?
I buy from U.S. Plywood. There's a U.S. Plywood place near where I live. We'd love to have you guys if you want to stay. But, if you need to leave, I understand. But,
I can only stay for half an hour, so.
oh, she's got to give up her spot. But, yeah, I'm sorry, we don't have any chairs. I was wondering if anybody was going to come, so I'm glad to see you.
Grab some from another classroom.
Yeah, there's other classrooms out there. Anyway, U.S. Plywood, West Systems epoxy, it's made up where it's about I make it where it's about as thick as mayonnaise. And I originally just started doing it just to keep it from running everywhere, So it's much neater, but, it's also a structural thing. That glass in there, it's really strong. And like I say, if you've got something that doesn't fit absolutely perfectly, you don't have to spend hours fitting your neck block or your tail block or whatever, wearing your arm out saying, it's pretty good, then it's good.
Is that your final glue up, or are you just gluing it?
No, I'm just gluing the two pieces together then. This third piece, I've got a pointer, I could use that. This third piece is just I'm using as a caul. These two pieces they put the epoxy on, I wrap them with that plastic like you get at Home Depot to wrap things up, or packages and stuff. And then I use a lot of that stuff. And then I put that caul on the outside and and just clamp it, overnight. And
I missed the noun on this whole, what exactly are you gluing there? That's,
these gluing up, this is the new tail block for the access panel.
and it's made out of,
Bendable plywood.
like, wacky wood?
I don't know.
Okay, bendable plywood, yeah.
Could be, but yeah, it'll just wrap around
Yeah,
round
okay.
things. It's very useful. And then so after I get it sets, I get it out and I, do some work on it, sand it up, make it look a little better. There's kind of the thickness of the epoxy I use after I mix the silicone with it. It's sort of like mayonnaise, and it doesn't run everywhere, but it's really good gap filler. Now, you know, cutting one of these in the butt of the guitar is just as simple as making a couple of really good routing jigs. As Robbie O'Brien would say, there's a pretty good pucker factor at that point. You know, by the time you've got a finished rim and you're gonna start routing big holes in it, you wanna be sure everything's just right every step of the way. But there's nothing hard about it, you know, it's just like using any other jig. You guys are probably a lot better at it than I am. There are a lot better craftsmen out there than me. But anyway, this is a Saddle Pal down here, and these are the jigs that I use to route the. Did you find a source of chairs out there? Good deal. And of course, you want to cut. I drill a hole and start routing, and you want to cut, of course, the smallest jig first, because you cut the big one first, and you got nothing left. We laugh, but I know a couple of people have done that, so I just want to mention that. And when you get through, once again, this is the same picture we had before. You see, you know, you really have great access to the inside of the guitar for repairs, electronics, you know, just visual inspection. If you want to make the inside pretty spectacular, that's the way to do it, you know.
And have you, do you do it in a way that you're preserving the wood from the rim so that when your access panel, the grain line matches all the way across? Or are you just using an offcut of your sides that is close enough?
Offcut of usually the back.
Offcut of the back?
Or sometimes just totally different veneer, something I think looks cool.
Okay.
You know, if I have a mahogany guitar and I use a real curly maple veneer, or we'll see some pictures of some others. Yes.
I noticed in an earlier picture that it was kind of undersized compared to the side. I was wondering if you curved above it, or if you sanded the
No, that
sides
is the
down.
curve. When you end up, when the sides are brought to shape, that block is the curve, and you have to round it over.
Okay.
You don't have to, but you
Yes, you
should.
you put it in and then you bevel the edge to match the
Exactly,
curving.
to match the curve. Yeah, that's exactly what we did. Good point, I appreciate that. Like I say, let's open discussion, open everything, anything here, anything I got, anybody's welcome to. Anybody, what I'm hoping is that some of y'all have a better idea, you know, along the way.
Probably have a better idea. I don't remember the first picture you showed, but is the end graft carried down through the access panel?
It can be. You know, it's whatever you prefer. I have done that. I think I've got a picture of one that comes all the way down the back, and it's like 12 pieces of black, white, black purfling comes down the back and it goes over the access panel. But sometimes we just do something different. Like, you know, we're Lame Horse and this is a logo we have, and sometimes we just put that on there. And you can see this is done from the back of this guitar. It doesn't match perfectly. There are people that will take a jeweler's saw and cut those sides out so perfectly that they can use that. And number one, I don't know that I can do that. Number two, I'm too lazy to do it. So, but it works either way.
So you're using a router?
I'm using a router and just routing all this out. Router with a, you know, I think I'm using a 1/2 inch bit, you know, with a bearing on it, a long 1/2 inch bit, because you really, and just taking an 1/8 of an inch at a time or whatever, and going down until we get it finished. And then this is what it looks like when it's cut.
Is the top of the router jig curved to match the back so those
No.
wings are curved, or are those wings in the same plane?
It's in the same plane. The top of the router jig is flat.
It's flat, okay.
Because I tried it that other way, but I just couldn't
So
control
those
it.
wings are coplanar, they're in the same plane?
They're in the same plane. Let's go back to, see that there's the jigs.
Okay,
See, they're flat on the top.
okay.
And here again, I use the bendable plywood to make these jigs where it's conformed perfectly to the shape of the guitar.
And by gluing that's two pieces glued together
Yes.
to maintain the curve?
I think that's 2 pieces a 1/4 inch or something, because I was trying to keep it from getting.
Too high.
They make that stuff in, I think they make it all the way up to a 1/2. I think beyond a 1/2, it doesn't bend very well. They might have 3/4, I don't know. They might. And then now I make the panel doors on the CNC, but every time I do it, I have doubts to whether it's worth it. Because this worked so well, I would cut, you cut out the panel door, it fits pretty tightly, and then I would just stick it in there and take a pencil and draw around and cut along that, smooth it off, put whatever I was gonna put on there, whether it be part of the back or the sides or veneer, fancy veneers or whatever, and then just take it down on the back end, the end that's fitting in there, just enough to bring it flush. And just kind of take a, flat sanding surface and just really massage it, try to get it to fit as perfectly as I can, which it isn't always perfect at all.
Do you bend it first?
Well, it's usually, I make it thin enough that I just I don't have
flexes.
to, yeah. And I glue it up in a vacuum, I put this part goes on oversize. And then I bring it back to the size, actual size of the panel.
But it's multi-layer.
Well, it's only 2. I use cedar for the bulk of that panel because it's really light.
Okay, okay, but that'll help hold the curve if you glue it up curved.
I glue it up curved.
Yeah, okay.
But, the sides are already done at that point. Everything's got its shape. And we're going to talk a lot about sides. And then on the inside, I've done this a million different ways. I've used threaded inserts. I've used T-nuts. And to be honest, I've never had a problem with any of those, but it just worried me every time I did it. That bendable plywood is a little bit punky, and I was afraid something might break out. And so I started putting in these these are 3/16 brass pieces, and I just drill them and tap them. And that works really well. There you can see where it's been tapped. You can kind of see how grainy and kind of funky this bendable plywood is. And then, end up with something that looks pretty good, hopefully. They can be real plain like this one. This one matched up real good. Or you can, make them as fancy and different as you want. This one is carved out. That started out as just ebony plate on there. And I carved out all the parts that are light colored and filled them with Mohawk epoxy putty made for wood. Does anybody ever use that stuff? It's great. It's the greatest stuff in the world. And we'll talk more about that too. But that's Mohawk epoxy putty in all the pockets, and then it gets smooth. And I mean, it gets hard as a rock.
Is that something you tint yourself, it's clear and you tint it, or does it come white like that?
It comes in every wood color there is, and you can get white or tint it, and you mix them. They have mixing charts. Like to get rosewood color, they don't have a rosewood. They have a kind of a dark red mahogany. It's not as dark as rosewood though. But you mix that, half and half with black, and you get a perfect rosewood match.
Yeah, you can tap it too, it's pretty awesome.
Yeah, it's really, it gets so hard. It gets hard enough in 20 minutes that I could throw it down on that tabletop. You'd think somebody had fired a gunshot in here. But it's not as hard as it needs to be. You kind of let it go overnight if you really want to sand it well and all. So it's great stuff. So anything else about access panels? Keep moving here. But like I say, keep all the questions and discussions coming. I need all the help I can get.
Do you worry about the longevity of that access panel since you used epoxy? I mean, 50 years from now, if somebody needs to do something if that somehow has gotten loose, I mean, at least with hide glue and tight bond, you can reactivate them and reglue them, where epoxy can't do
Epoxy
anything
will
with
melt
that.
a lot easier than hide glue. And that's one reason I put my fingerboards on with epoxy. You can lay a heat blanket on there, in about 20 minutes, you can just peel it up. But do I worry about it? I don't know, maybe. I think it's for me, it's better than, I don't use any tight bond. I use hide glue where I think it might be important, you know, gluing on braces and things like that. And then I use, and it's not that I have anything against hide glue so much, it's just that I don't have enough open time. And with epoxy, you can get the slow setting stuff, and you can work on it all afternoon if you want to. So, the next thing we're going to talk about is laminating sides. Now, one fellow here said he had done it. Who was that? Yeah, Tim. I forgot. Yeah. Why laminate sides? Talk about durability of a guitar over time. I mean, what's the thinnest thing on the whole guitar? The sides, probably. Maybe the top, but probably the sides, depending on what you're building. So, you can see, we've all seen this. Here's an example of the other reason we want to laminate sides, is we're taking all of the stress off the sides, holding their shape. The glue joint does that as we laminate it. And this is a friend of mine. This is I'm not going to say what brand of guitar it is. A well-known brand of guitar. And he's a repair guy. And this guy asked him to come and install his pickup with a preamp and equalizer and stuff. And he drilled it, cut it, drilled it, and he tightened down that first screw just a little bit. And that side's under a lot of tension. That's the reason it does that. So the whole purpose for me of laminating sides is to remove the tensions that go on with bending sides. They all want to spring back on us, they want to go back. But after they're, removing the tension that happens as we glue up this thing to make it hold its shape. And so some people don't want others to know that they laminated the sides, so they get a veneer or take a regular side and thin it down with the same material as the outside of the guitar. Like this one's Madagascar in and out, but that's a laminated side. And but making it inconspicuous has really never been my forte. So I usually use some contrasting material, like curly maple. If it's a dark wood, curly maple or bird's eye or something like that. If it's a light wood like myrtle or something, I use ebony on the inside. Or I like the white oak is good. It's nice and light and it's figured, And this also shows, this is our access panel thing in, kerfing in. You can see the difference here, how this, I used to make these things thicker, I don't anymore, it's not necessary. But this shows you, how it's, planed off. You can see that distinction, I think you asked about, between using that as the kerfing.
Is there a cross-grain center layer in that laminate?
No, but I have used Tyvek. And I know people that use Tyvek and it works great. It's really more the glue joint, in my opinion, than anything else. I'm using this thickened epoxy structurally, and knock on wood, I've had a few accidents with these guitars. One time I had one hanging from a ceiling like this, and the bottom of the guitar was probably right there. and it fell and hit the floor. It wasn't a concrete floor. It hit the floor and bounced, and I thought, picked it up. You know, it didn't have any finish or anything on it at that point. Nothing happened, you know. It was really stable, yes.
How about the thickness of your lamination? Do you go in like near full thickness on the outer lamination, just put a veneer on the inside?
I usually put a veneer. There are people that will, and I thin the sides down more than, you know, I usually take them down 75 thousandths or something, you know, less than 2 millimeters, and then put the veneer on. The veneers are about 25 to 35 thousandths, 25 to 40, what they are.
You end up with an overall thickness.
And you've got that glue thickness, that little bit of glue in between that's thickened with that silica, really strong structurally, and,
2 plies or 3?
sorry?
2 plies or 3?
I just use 2-ply, but I started out using 3 because, I mean, I stole this idea. Irvin Samaji told me about this, and he was trying to hide his, you know. He made it out of Indian rosewood. He took another Indian rosewood side and thinned it down to, you know, 40, 50 thousandths or something, and laminated it on there. So it did. For some reason, he wasn't comfortable telling people, you know, using the word lamination, you know, like plywood or whatever. So, yes, do you have a question?
Couple questions. When you use this process, can you do angled stripes to it, like do like a, I don't know, bloodwood on top and maple on the bottom and have it angle around, and when you laminate this all together and have it bend successfully, before you do the bend, will the heat melt that epoxy enough that you would break that joint there, or is there a way to, could that all be incorporated into something like that where you could have some kind of decorative line going through using 2 different species?
Do it before you bend?
Before you bend.
So I have inlaid sides on the outside, you know, before I bent, and I use Type Bond 3. Type Bond 3, talk about heat and moisture resistant. I'm a veterinarian, or used to be. I still am technically, but I'm full-time luthier now, retired from veterinary medicine. And one time I had a guy that was making some fretboards for me. They were out of phenolic type material, and he couldn't, you know, they weren't perfectly flat. He was doing them on CNC, and so he said, I'm gonna have to glue them down to a board. I said, okay, well then we'll just get it off. You know, it won't hurt to soak it in water or whatever. And he glued those down. He didn't know any better. He went to Home Depot. He bought Type Bond 3, and he glued those down. And you know, I couldn't loosen it up with a heat blanket. I tried steaming it. And I took it to the vet clinic and I put it in the autoclave. We're talking 3 atmospheres of steam. Didn't budge it. So that stuff, if you want something heat and moisture resistant, I think that's the stuff to use. And I think you might get it done with that.
And if you did that, would that be the process that you would do it with, like, so you have a point at one end and it widens and comes around to the lower bout?
Maybe so. I mean, I wouldn't do it because I'm not that good at crafting. But if you were going to, I mean, the only way I would ever attempt it would be to attempt it before I bend.
Right, and do it with laminates as opposed to solid woods that you would glue together, just like a top and a back, where you have a very thin seam.
Yeah.
Because that probably would hold up to the heat of the bed.
I'm not sure.
Am I making sense?
I'm not following you right there.
Well, I'll stop. Maybe.
Anyway,
And the other question was, can you buy already laminates, thin laminates for siding and tops, and that plywoods that you can make out of your car?
I mean, not that I've seen. You can buy, of course, fiber laminates, or maybe, you know, Gurian Instruments could probably supply you with some thin 40 thousandths, you know, laminates. You know, either fiber or thin wood, you know, like they do for purflings and stuff. I buy layups of purfling that are uncut. That's how I make my bindings. I glue the wood onto that first with Type Bond 3, and then cut the bindings. Everything fits perfectly, and then bend them. So the Type Bond 3 will hold up in a bend.
So you don't laminate the shape.
Yeah, I do. We'll move on. I think some of your questions are gonna be answered. But I wanna show you the main reason that I wanna do this. This is one that's been laminated. It's got the blocks laid in there. This is a animation here. But you know how you put it in there and you put your spreaders on there and you push it out to get it in the right shape? Well, this is, if you've done the proper lamination, this is, to heck with the spreaders. This one has been done, and there's the mold. Don't you, whoop, it didn't play, did it? You don't need any spreaders. You've got a perfect fit there. Right in the mold. So here's how I do it, and I'm sure there's a million other really good ways, but I'm using a veneer here. I've got my bent side, and I've got the veneer, and I butter up the side with the thickened epoxy, and put it together and wrap that side and veneer in that plastic, once again, Home Depot. So then I can put it in the mold, and you know, I'm just stupid because it took me a long time. I was holding this down close to shape with tape, but you know, I just took that same plastic and just wrapped the whole thing, and it really holds it well. And then I use vacuum, and you leave that in there overnight, and man, that side is as solid as, there's no spring back of any kind. Now, how is this going to help? I mean, obviously, you know, this is a good structural thing. There's what we end up with after we get it out of the mold. Oh, or just, this is the same deal. I was going to play it again, but we just saw it. So, and this is looking through just to show how the you know, contrasting veneers. People seem to like them. But if you don't have a vacuum setup, you don't need a vacuum setup to do this. This is not mine, but this is somebody's. I had one very similar to this for a long time. I had a piece of real thick commercial rubber back carpet that was cut, and I used it as a caul with a piece of metal on the back, and I just laid them up in the mold and had 1,000,000 clamps and clamped it. This is somebody else's version of the same thing.
And that wrapping plastic doesn't stick with the epoxy?
Oh, maybe a case, I mean, nothing to amount to anything,
Okay.
no. This was mine. This is actually mine. This is how I was doing it before the vacuum. Yeah. You can see the little bit of carpet in there, and then this is there's a metal caul laying on top of it. But it's not hard to do. It's an extra step, but I think it's worth it for a couple of reasons. You get that stability. You're not going to crack a side. But the main thing is, you know, you use clamps, spreaders, and you spread out that, you're forcing those sides into the mold because they're wanting to return to their natural shape. And if they're not laminated, there's really nothing to stop them. And so how do we do that? How do we prevent that? Well, we force it into shape in that mold, and we glue the top and back on. Well, that inherently adds stresses to the system, you know, to the top and back. That top is no longer sitting on like a drum rim. It's sitting on this thing that's kind of, you know, you've got this top that's maybe 90 thousandths, 100 thousandths thick, maybe thinner, and it's just, you know, it's wanting to twist it this way and that way. And I don't use spreaders. I don't glue the top and back on in the mold. There's no need to. So they are perfectly free to move as they're glued on to that rim.
And the little side straps you have on, those are just purely decorative at that point, because you don't really need them for keeping the sides from cracking.
That's kind of one of those accidental things that, I hadn't been building guitars very long, and I was building a guitar for a guy, and I was gonna put some side braces in it. At that time, I wasn't laminating sides. And I didn't have enough material to really make it work. So I laminated up some material for looks-wise, you know, and put it in there. And I was out at, this is way back, this is like, you know, 1996 or 7 or something. I'm at LMI, and Todd Taggart sees a picture of it. How many ever remember the old LMI catalog before the internet, you know? And yeah, that's where we got all our information, right? I mean, they charged $125 or something for the catalog, and it was worth every penny. It was all the Lutheran information in the world, and there wasn't any place else to get it. But if you got a picture in there, man, that's like being on the cover of the Rolling Stone. And Todd put a big old picture of the inside of that guitar in LMI, and so, you know, I didn't know squat, but man, I got some instant credibility. So from that day forward, they all had to be fancy, check different, so we do. But structurally, I don't think they do anything. Mine don't, some people's mine. I'm sure they help if you don't have the sides laminated.
I like the reverse lining too, how you've got it inverted with the curves going towards the side.
That's another, I want to stiffen up those sides even more if I can.
It almost looks like solid
I
lining.
don't want to lose any vibration and those sides expanding.
Reverse curving makes things unbelievably stiff all by itself.
Yeah. It helps
It's
a ton.
remarkable. I glue it on and the sides, even not laminated, don't move. They're just there.
They also are easy to make.
Well, they're no harder than otherwise, but gluing them on that way, they make an enormous difference.
And I don't know, I guess this is just a show, I don't know why this is in there, but there's another example of the side braces. It's just purely decorative, you know, but it's a way to set things apart. And look at, this is a Koa guitar with the ebony lining. And then this is looking in from the access panel. So if you're doing stuff you're proud of, you know, people can see it, and I think what it translates to them is, man, if this guy's taking this kind of care on the inside, this must really be a great guitar.
And do you ever feel the inside of the sides finished there? They look shiny.
They are. They're finished. All the sides are finished. I mean, not, you know, not polished out and that kind of thing, but they all have finish on them. Anybody that ever painted one side of a board and went to lunch and came back? I mean, to me, it just it makes too much sense not to finish it. Yeah. So, yeah, that's finished. That's white oak. And these are the side braces that match up with that access panel we saw that was all use that shape. So, okay, anything else on laminating sides?
You put finish on the inside of the top as well?
I do. I shellac the inside of the top, and I'll use, I used to use just, and I still do some, depending on the wood, I'll just use vinyl sealer and lacquer on the inside of the guitar, but, you know, if you're using rosewood, especially Coca-Cola, you know, the pigments just run everywhere with the lacquer all over the braces, and so I've started using a water-based stuff, another Mohawk product. I'll just throw this in. It's called Finish Up. This is the greatest stuff in the world. You can get it gloss or satin. You rub it on. You just wipe it on. You don't really rub it on. You wipe it on. It'll stick to anything. And I haven't found any finish yet it didn't stick to. You know, the finish was roughed up. And I've gotten where I don't do my own finishing anymore. I'm not even good at it. But if I have to do a neck or something, I can wipe on about 8 coats of that finish up in about 2-3 hours. And after I'm doing other stuff in between, put a coat on every 30 minutes or so. And the next day, you know, I can sand it and buff it out and it's finished. I could probably do it that evening. One time I was in a bind for a demo on that stuff, and I did it all in 2 hours. I finished it, sanded it, buffed it out in 2 hours.
That's a water base.
It's a water-based polyurethane, but it's not your typical, you know, there's something different about it.
But it's drying, not catalyzing.
No, it air dries, but it dries quickly. You know, I went to a Mohawk finish repair class, and I got there and I could see it was all about furniture, you know. And I thought, well, maybe I'm gonna learn something. I got so, if nothing else, just the products they turned me on to, like how to use that epoxy putty, finish up, that stuff. It was well worth the money.
And it's pretty hard, it sands well?
It's hard as a rock. It's really hard.
Can you use that on the inside as well as the outside, or is that just?
You can use it anywhere, but I use it on the inside now on woods, resinous woods, you know, like I'm afraid the color's gonna run and discolor the braces and things, you know, look sloppy. I'll just rub it on the inside, just wipe it on. You know, it's a good, I've used it as filler. If somebody just had to have lacquer or filler, you know, finish with that stuff. You can put a lot of coats on quick, sand it down flat, and then spray lacquer on top of it. Sticks to it good well. Let's see, what are we talking about? Oh, braces. I really like to laminate things, you know. So this, we laminate all our braces. Couple of reasons. Fred Carlson started doing this. How many of you know Fred Carlson? If you don't, do yourself, you will enjoy this immensely. Go to YouTube and Google Fred Carlson Oracle. And you'll see some of Fred Carlson's work. Fred Carlson is the greatest luthier in the world. No offense to any of my other friends, but nobody can touch Fred Carlson. But he's just hidden away in the forest up south of Santa Cruz and builds one guitar about every 2 years. It takes him 2 years to build it. When you see the article, you'll know why. But Fred started doing this, and I was out spending some time with Fred, and I picked up on this, and he started doing it because he didn't have to try to shape his braces to the you know, the arch of the top, whatever he was putting in there. And he had, if you see Fred's work, you'll know, he has some boards that he glues tops up on. They'll be flat in one place and arched in another and more arched in another. And, you know, it's a real problem to fit braces to those. And Fred started doing this because he could, a 1/4 inch thick brace, you know, he could press down and make it conform to any shape with a go-bar deck, but he couldn't do that with a 1/2 inch brace, you know. So he started doing this, but it really, when I saw it, you know, the light came on, boy, this made a lot of sense to me, because there's, what do we want out of a top? We want it to be as stiff and as light as possible, you know, the bracing. All the strength in the bracing is in the vertical part anyway. So this laminate is much stiffer than just a regular brace. It conforms perfectly to the top. And so we can carve it down thinner and smaller and have the same amount of strength. And I've done some tests, you know, just some deflection tests pieces of bracing from the same board. I'll take a 1/2 inch brace, put the weight on it in the same place and measure the deflection, and then do it with a laminated brace. And it's no comparison, you know, it's, they're so much stiffer, and they weigh the same. I mean, that hide glue that's in the middle there doesn't weigh anything, so, you know. To me, this just makes a lot of sense. And I think maybe I'm fooling myself, but I think the X brace, the joint is better because I'm dealing with a full thickness here and a full thickness going across it this way, than butting up to it with other pieces. But rather than, you know, notching out a couple of things, you know, it tends to split at the end of the notch along the grain and stuff. So I really think this makes for a stiffer. I used to sometimes fool with I could kind of tune the top a little bit after it was done. I put a little spruce disc right there on the X brace, and if it sounded too stiff, you know, I could make it thinner or end up popping it off or whatever. But I don't ever have to do that anymore, I find.
Are you gluing these with a vacuum also?
No, I'm just using a go bar.
Just stack them up with the glue and a go-bar bit.
Yeah, glue them, you know, one layer at a time. And then I'm gluing them on, you know, this is nothing new. Anybody that's read any of Samaji's work, that's about, you know, the brace does have more stiffness flat sawn than it does quarter sawn. It's more stable quarter sawn. But when you're dealing with something the size, you know, it's a 1/4 inch square, 20 thousandths by a 1/4 inch. It's not going to be too unstable anyway, as long as it's a good piece of wood, you know, not a lot of run out in it or anything. So it is stiffer this way, and I've done deflection tests to measure that too, and it's true.
Stiffer plain sawn.
It's not as stable, but it's stiffer.
Did that affect the tone too? Did you notice anything?
Well, I think the stiffer the brace is and the lighter you can make it to get the same amount of, you know, of support for the top there. You know, I'm not sure what braces do. You know, I've seen guitars that didn't have any braces. People built them just because they said they could, and they, you know, they did. And I've seen people build these, I call them laminate tops, but which I don't do. But you know, these
Double tops?
double top, and without braces. I don't think they sound very good. That's just my personal opinion.
I mean, traditional teaching tells you, you know, that you've got an element of spring that's supposed to be built into that brace that you notice, and it seems like you've kind of bypassed that by making a laminate that by design conforms to it, but the trade-off is the stiffness, so I don't, you know.
Well, I don't really want any spring, you know, and this glue joint, well, you know, this glue joint takes the spring out of it.
Right.
I don't want any stresses on that top. I want it just to be as free as possible. And that's how I glue them up.
Do you radius the bottom of the braces?
No.
Does it affect the
They'll
projection?
conform perfectly. Hey, Steve.
Okay.
They'll conform perfectly to the shape of whatever you've got them in here.
Is it the hide glue gelling up and getting a little stiffer? Because I think about doing that with Type-On, sliding all over the place.
Well, you know, that's the reason, the theoretical reason for using hide glue, is that it's harder, you know, maybe it's gonna sound better.
But I mean, gluing it up like this, if you had those.
You know, any brace, when you glue it up, it wants to move a little sometimes.
I'm kind of confused about how stiffness and stability are like different. And I'm just wondering how.
Stability, I'm talking about affected by moisture, heat, you know, temperature, that kind of thing.
I'm wondering how you weigh that, like, because the stiffness would give it more vibration, but I mean, do you have experience with those braces warping or anything?
No.
So there's really.
I think when you're dealing with something like a back, you know, and it's flat sawn, now, I'll be honest, I don't see a whole lot of that in a back either, but that's where it's most likely to happen. I think if it's not built under the proper humidity conditions, you know, it's more likely to happen. And, but, so, you know, tops, yeah, you want them quarter sawn, you can get them, but, and I want these braces, you know, to have no run out if I can. Not always possible in brace wood, you know, but little run. And there's a guy over there in the exhibit hall has the most beautiful Adirondack brace wood you've ever seen. Perfectly quartered. It's wonderful. But, and George Loudon, a friend of mine, George Loudon, he's more concerned about run out in the brace wood than he is anywhere else. So, and there's the finished thing. These are, you know, sort of pyramidal braces. Like I say, all the strength is in the height, making them wider. The strength is exponential function in height, and it's just an additive function in width.
It's a square of the height and linear to the width.
Cube at the height.
It's a third pH cube.
It's a cube.
Any questions or discussion about?
Do you make your braces thinner then because they're stiffer?
Carve them smaller, thinner.
Approximate width, 1/4 inch?
I start out at 200 thousandths, 0.2 inches width, and they stay that at the base. And I start out with them a 1/2 inch high, and they stay pretty much a 1/2 inch high at the center of the X, and then, you know, taper linearly, pretty much straight out to near the sides, and then they're, you know, dished out.
And you don't notch those into the kerfing at all? They just taper down to nothing before that?
And I don't know if that's a good thing, but I can tell you in almost 30 years I've never had a problem. And the only reason I do it that way is that's the way I learned it.
And so stacked up, you're 1/2 inch high. You have 2 1/4 inch heights, so 1/2 inch high is what you end up with.
Yeah, exactly. And then start with that and then carve them down.
Yeah.
Is there a reason why you don't use epoxy to laminate those instead of, why you're using high glue instead of epoxy?
Well, I think that epoxy adds a little weight for one thing, you know, and I don't want the top to weigh any more than it has to. And the high glue is just a lot better. It's more reversible. Like I can easily take a fingerboard off a neck that's epoxied on with heat, but applying heat to a brace and getting it off, you know, it might be really tough. Whereas a little hot water, you can get the steam and get those braces off with the high glue. Yes, sir.
Since you're talking about glues, my experience with high glue has not been the best. Every guitar, and I live in South Georgia, and most of my guitars are being played outside in the open air venues. And every guitar that I used high glue on, the bridge popped up eventually. And I even had 2 of them that the braces came loose. And I've built many guitars with pipe bond too and never had one issue. Am I doing something wrong?
I don't know, possibly, because you know, there's a lot of different strengths of high glue too. And I use the strongest one. It's what I think the gentleman has passed on now, but he's like the great guru of high glue. Can't remember his name, I'm sorry.
Borg?
What?
Borg out of.
Borg, yeah.
He's still alive.
Is he?
Yeah.
Well, I called up there and ordered more glue, and I talked to his son now, so I thought maybe he passed away.
Well, I haven't seen him in the last
But that guy knows everything there is to know about hide glue. And he told me, I think it's 320 or something. He said, this is the one all the good violin makers use. And he said, this is what you want. You know, you can get it at about 120. And then there's something in between, but.
Like 120, 180, 240.
Yeah, I think it's 320 is what I use.
You can mix them. If you got it as 500 or 600, take the lowest one, put any number you want.
I'm pretty sure it's 320. But, you know, I'm not gonna say I've never had a bridge come up, because I can think of one for sure. But, you know, I think back, and it's probably poor workmanship, you know, on my part. But probably just didn't have it fitting well enough. But that's one thing about, I mean, with hide glue, if you've got a gap, you're gonna have a gap after you glue. There's no gap filling with it at all. You know, it shrinks back to nothing. That's one of the things good about it, self-clamping. You know, it pulls things together. Like, that's one of the main reasons I use it for binding. Because, man, it will suck that binding in and down, and I have a lot fewer binding gaps using hide glue than anything else. But, yeah, but if you've got a gap, you're gonna have a gap when it's done. It's not like that epoxy. But I had a guy that the guitar fell over on its face, and the neck hit something real hard. It's a redwood top, which is pretty soft, you know. But the bridge did not pull off the top, even with wood fibers. The whole top just cracked and came apart, or it was about that big around the bridge. So it was holding pretty good. But I don't know what to tell you. I wish I could. But I use it to places I think it matters. But things you want to reverse, like a bridge. But you can get a bridge off with Titebond easy enough. But it, you know, Titebond, it's kind of like it never goes away. You know, you can't, and you can't glue to it. You can't glue Titebond to Titebond. You got to spend a lot of time trying to get all that Titebond off of there, and always worry, did I get it all off, and this and that. So, you know, hide glue will stick to itself. So that's why I do that. I don't profess to be in.
What kind of work time are you getting with the hide glue that you're using?
Not much. You know, 30, 45 seconds a minute.
So your shop's not heated to 95 degrees? Or?
No, but I do I get more time. I take a heat gun, you know, and go over the surfaces. Like when I'm binding, I'll do 3 inches at a time. And I've got a little automatic tape dispenser. And you push that and it gives it just the right length of tape. And I'll paint the hide glue on everything, you know, enough that it squeezes out. And first I'll heat it a little bit with the heat gun, and then I'll paint the hide glue on there and tape it together. And I mean, it just sucks to itself. It's good stuff for that. And it's not hard I don't find it hard to use. Some people might, but. You know.
Did you say your X brace isn't notched or is?
It's not.
It's not?
And I'm in good company on that. Fred Carlson does notch his braces. Samaji doesn't notch his braces. I'm sure there's a lot of others too, but those are two that are a lot better luthiers than I am. And then the last obvious place that I think we can increase our stability and our sound quality is with necks, you know, multi-laminate necks. This one is what? 11 piece, but I think, you know, a 3-piece or a 5-piece is plenty good. But, you know, we can, this neck's never, you take a neck like this and you put a monocoque on it, you know, a fingerboard, it's never going to let It's never gonna twist. It's perfectly stable. Now, sure, you have to adjust the truss rod, you know, maybe, but it just eliminated all the problem with a one, that you have potential with a one-piece neck twisting. Especially, like, we built a bunch of these 6-string banjos, my son and I, a bunch, some. And, you know, that neck it's the ultimate cutaway. It's 22 frets to the body. So there's a lot of stress on that neck. And we've been building those since about 2002. And knock on wood, we've never had a problem with any of those.
Hey, have you heard of anybody who knows anybody that's messing with the adjustable neck set angle? You know what I mean?
We're getting to that.
That, okay.
That's the heart of the program. We better hurry.
All right, that's the one I was,
That's what you want. We'll rush through this neck because it's all pretty obvious. But it allows you to do some things you probably shouldn't do. Or like this guy built this guitar from. He's actually a guy that had the rattlesnake rattle in his guitar. He's a cowboy singer, and he wanted the neck out of the same wood, or at least same wood as the body. Well, I had a board, but man, I mean, look at the grain on this thing. You wouldn't ever build a neck out of that.
Or a rattlesnake for that matter.
Yeah, you might use it to hit a rattlesnake, you know, with it, but it's about all it'd be good for.
a nice campfire.
But this guy insisted, and so, you know, I took the Babinga, the guitar is Babinga trim all over it, binding and backstrip and stuff. And, you know, put that Babinga and these, this right here is
Oregon myrtle?
the wood, this is Oregon myrtle, but these little strips, sometimes we just use veneers, but what I really like to use is, you know, phenolic, some kind, or they used to make this stuff called diamond wood. I think it's back in production, where they take birch and they'll dye it any color and they mix it with epoxy and put tons of heat and pressure. They reduce its size half. So they start out with a 1/4-inch piece, they end up with an 8-inch piece that's impregnated, 1/8 of an inch thick piece that's impregnated with epoxy. So it's really stable. And so so obviously this prevents neck problems, but also the stiffer your neck is, the more energy you're getting down here to the body. The more flop you've got in that neck, you're losing. Acoustic guitar is a very inefficient machine, and the more flop you got, the more energy you're losing. I don't want to lose it in the neck. I don't want to lose it in the sides. I don't want my top and back under any stresses. So these are just pictures. This one is phenolic, I think. You buy that stuff in 1/16 of an inch thick sheets, and I just cut it up on the table saw, you know, with a laminate blade, and put it in there. It's pretty hard on tools, but man, is it stable.
And you put that laminate up, you use epoxy for that?
What?
You use epoxy
Do
for that?
epoxy for that. And here is the, you know, if you're into ecology, you know, you can build 3 of these necks from one block that you built a one-piece neck with. And I like that. I mean, it's cheaper. If you're not into ecology and you're just cheap, like me, you know, it's cheaper. It's just a way more efficient use of materials. But it's stronger, it's better, you know, than cutting out a one-piece neck. And stack the heel if you're going to use a heel. There's some one-piece necks, and then there's a 1-inch thick laminate neck about to be made. Here's some of that diamond wood. Comes in solid colors, but if you're really crazy, you can get this stuff, you know. Or you used to be able to. And then this is just plain old Garolite, which is the super hard phenolic. I was talking to the guy over in the exhibit booth that has this, what is it, rockwood? Rich light. And wondering if they had it in 1/16 of an inch, and they don't. But they have it in 3 millimeter, which is pretty thin. I think we might get some, because it's not as heavy as this stuff. It's not near as hard on tools. It's phenolic, but the way he explained it to me, it's just not compressed as much as Garolite. And Garolite is like a rock.
Is that
All
the
right.
paper Garolite that you're talking about, or the cotton Garolite?
It's Garolite's paper.
Okay. I mean, they have a whole variety of different.
Or the one I use is, I
Yeah.
don't know that much about it. I could be. All right, now we're gonna get to the crux of the talk, and that is the neck adjustment system. And, what is the bane of the acoustic guitar? Rising playing action, or even falling playing action if you know, take it to a real humid place and it swells up. And it's difficult to do anything about. So, you know, even though we try to control humidity we build it in, you know, these guys that take these guitars, they don't, most of them don't take care of humidity. They should. Some of them do, but not many. So what do we do to try to fix it? You know, we take the saddle down to nothing. I didn't do this work. These are just examples. Or, you know, if it's swollen up and the action's gotten too low, we put in a real tall saddle. And either the saddle breaks or it breaks the bridge because there's too much stress on it. Or, you know, we can steam the neck off and reset it. And, you know, that's a real high pucker factor job. You're going to damage the guitar, the wood. You know, there was a time, some period of time, maybe the 90s, I don't know, and Martin had a lot of neck blocks that were laminated. Evidently was something that dissolved pretty easily under heat and moisture. And some guys went to steam necks off of those and the whole neck block just comes apart. Talk about a mess. So if I can avoid that, I want to. You know, all these things that can go wrong. Now, there have been some good ideas. This is not a new idea. This guitar is made about 1860. Martin guitar with this key in it you turn to adjust the pitch of the neck and change the action. This is a 19th century guitar, Hal Orme or something like that. Some of y'all might know. And you know, they fix the bottom of the heel with a little bit of a bendable, you know, kind of a malleable piece of metal, and then they put in these turnbuckles, or whatever you want to call them, up here to change the pitch of the neck. As you can see, the fact that this was fixed and this wasn't made it prone to things like that, but it was a good idea. This is one from the 50s. This is a K guitar. This is not a bad, and they had this shim that's oval, and the neck can pivot on it, and inside you just loosen this thumb screw, you know, and and pivoted the neck to where you wanted it, and tighten it back down. Then there's this great idea Gibson had. We might as well glue several ounces of lead to the underside of our guitar, underside of the top. That's going to make it sound real good. But you could get the intonation right and set the action pretty good. You just killed all the sound in the guitar. And I just put this in as an example. This is another Hal Orme guitar. There's nothing new. I should have said this in the beginning. You know, most of these ideas I have stolen from somewhere else or partially stolen from somewhere. There's nothing new under the sun. I think Bob Dylan deserved the Nobel Prize because of one thing he said more than anything else. And he said, all the great thoughts have been thunk and all the great sayings have been said. And there's nothing new under the sun. People take claim for fan frets, and, you know, there's examples of them in the Middle Ages, you know. And we got a little wedge going here, you know. This is in the 19th century. There's a lot of methods to do this. You know, some people come up with different things, some more complicated than others. You know, this one, you take the tension off the strings, and you have a light, you go in there and you adjust some things. And this is a Rick Turner modern version of the How Army. He made it, took the bad parts out of it, and it works real well. Some people don't like the cosmetics of it. It's always gonna look a little different, I think, no matter what you do. Here's another one. This is one,
The Babbitts.
yeah, and he put that in and turn it in the bottom, and it, you know, works well. I think he sold this to Martin, didn't he?
Yeah, it was short for a while.
And then they just, they buried it, you know?
It had some issues.
It disappeared
Yeah.
once he sold it to Martin, you know? It's like the Tucker, you know, the Tucker car, you know?
Well, Babbitt still makes them.
He does?
He still produces
Okay.
guitars, yeah.
And then there's the Taylor way. Well, you know, I really gotta congratulate Taylor, because the cheapest guitar they make, you can adjust the action on. The downside is, you gotta take it apart completely, put those shims in, hope you get it right, string it up, see, if you didn't, then you take it apart again. But you can do it. And, I mean, you know, a Taylor 200, you can do this on. So, it's a great idea. This is a system that my son and I had, and it worked pretty well. We could do it, we could adjust the neck, but players tried to do it, and the next thing I knew, they had the neck on cock. You know, it was a disaster. So we said, we got to get something better. And my goal, I wanted to come up with something that players could do foolproof. And I wanted all the parts to be easily available, not to have special parts made, you know, at a machine shop or that kind of thing. And I wanted it to work. And a guy in we have a local luthiers group there in North Texas, and there was a Scottish engineer in there that came up with this idea, Derek Lambert. His idea was to incorporate a tuner into it to give you a more mechanical advantage. And it's a great thing, because you drive a 1/4-inch bolt, who knows what the mechanical advantage on a 1/4-inch bolt is? The threads. It's 34-to-1, that's pretty good. But then you multiply that by 18, and boy, you've really got a fine adjustment. You know, it's a 600 and something to 1. So this, we'll get into what we do with this, but that's a picture of it. And here's what this guitar has it. You know, it's fairly cosmetic. And this is how you adjust the action to that hole under there. It doesn't need this heel, but this is a little faux heel we put on there, just because it hides the joint between the body and the neck, and makes it a little more aesthetic. Oh, Megan Wells was here a minute ago. She left, but somebody was asking about taking the thing down. This is a guitar that my son and I made with Megan Wells, speaking this afternoon in a group of females. And we took this pattern on the back and incorporated it and brought it all down to that. So, all right, well, let's talk about, we got about a half an hour left. We'll talk about how we do it. And like I say, anybody at the end of the talk, if you want to give me your email address, name and email address, not going to sell it, not going to give it to anybody else, but I'll send you everything I have on this. It's open source. Maybe you can help come up with something to make it a little better. But I'm the Pied Piper of adjustable playing action. I want every guitar to have it, last forever. Here it is. Let's talk real quick. Lately, we've gotten into trying to find different stuff all the time. Gotten into the 3D rosettes. This one's got one. If you have a chance, I haven't made a look at it. This one, these are little frames, 3D frames out of a Binga, pearl in them. Okay, this is everything, all the hardware you need to have an adjustable neck. And there's nothing there that's not readily available. You know, get this tuner from LMI, Stu Mac, all parts. It's a bass guitar tuner, 18:1 ratio, and everything else there you get at the local hardware store. So you don't need any specialty parts at all. You just gotta set it up and modify it, okay? And the neck block, these measurements are not exactly right. Don't bother to write these down because I've changed them a bit, and it'll be in any new information that I send you, but they're close. And but this is the shape of the neck block we start out. I usually just print, I've got a JPEG I just print out, and I'll slap it on, put some rubber cement on a block glued up, and then just cut it out on the bandsaw. And the thickness is pretty good here. I've also narrowed it down. It doesn't need to be 3 inches wide. It could be 2 and, I think I'm down to about 2 3/4, 2.5 now. But this is with the, you know, the neck block glued in, what it looks like. I made this jig where I could cut out a pocket in that neck block. So it looks like that. And I cut it about 5/8 of an inch deep. My neck started out 3/4 below the fingerboard. And that's where the neck is going to connect to the guitar, in that pocket. And I make the pocket, this is something you don't have to do, but we'll see it. I make the pocket 2 inches wide, and I cut the neck down to 2 inches where it meets the body, just so the fingerboard hangs over and you don't see the joint. It's a little more cosmetic on that one. But, you know, my electric, there's no reason you have to do that unless you wanted to. So there's really 3 parts to this. What you do to the neck block, what you do to the neck, and then what you do with the tuner to make it work. So you get your neck ready and scarfed and everything, and the truss rod in there, and I lay the fingerboard on there, get it placed properly, and just secure it with brads like probably most of y'all do, so I can take it off and put it back on in exactly the same place many times, because I do that usually during this process. If I was a better luthier, I wouldn't have to take it off so many times, but I do. It's like I could never make a guitar with a glued on neck, because every time I build, you know, the neck could come off a bajillion times back and back on. So there we're seeing how I cut the neck back, just so this is where the fingerboard's going to come to on either side, that line. And I just want to see the fingerboard hangs over and you don't readily notice the gap. But, and you can look this guitar over when we're done here. But it's you know, it has a floating neck similar to what an arch top would have, you know, the look of it. Then get the neck in there lined up, and I've drilled holes in the fingerboard. Like this is a 12 fret neck, so between the 12th and the 13th, and then between the 14th and 15th, and I mark those onto the neck through the holes. This one I don't drill through the fingerboard. This is where the tuner's going to go, but I've got it drilled. I line everything up. I've got this little jig. It's just a straight line is all it is, with holes down here where my, you know, bolts are going to be eventually. And through those holes, mark where those holes line up with the top of that pocket, the neck block, because that's where I'm going to put the threaded inserts for the neck to bolt down. I want everything to be straight and, you know, lined up properly. And just use threaded inserts and glue them in. I do use a struggle, I mean, I always got them in, but finally I got smart enough to use a little step-up bit with a, pretty low angle on it. How those inserts are angled, and makes it a lot easier to get it in there.
What do you glue in the inserts with?
Cyanoacrylate. Clean them off with naphtha first, so, because they're real oily usually. Okay, so here's the top of the neck, drill the holes out, bigger. So I'm gonna put these T-nuts in here to act as a stop, just a stop for bolting down the neck into the body. If I just had wood there, you can just keep tightening it and your hole gets deeper and something. And so I just want a metal stop there. These are T-nuts, and after I get them in there, okay, there they are, they're installed. I drill out the threads out of the inside. Use a number 10 Allen head bolt to hold the neck on the guitar. And so if I drill them out to like a 1/4 inch, it gives you a little bit of slop, to adjust things. A little bit of slop is good in this system. You can buy a tuner, Goto makes 2 classes of bass tuners, for example. And one costs $2 or $3 more than the other. Well, the more expensive one, man, nothing moves on it. It's just perfect. Well, the cheaper one, you got a little play. So you can, and you'll see how that might be important later on. In fact, now I'm using Mighty Mike tuners that Stu Mac was closing out, the cheapest bass tuner I could get, Then I turn the neck over, and I want a fulcrum on the underside of the neck for that neck to pivot on. So what I do, I just use a fret. And I don't have a picture of it here. Somehow it didn't get in here. But we'll talk about it in a minute. I have a slotted little piece of aluminum. You can slide it with a file or whatever you want, that screw down into that pocket for that fret to sit in, so it keeps it. When you tighten it down, it'll pivot still, but it won't rock side to side. So this is where we're getting. We're going to put a barrel bolt in here, a barrel nut. I mean, this is where the barrel nut's going to go. And so there's kind of what you got when it's done, the neck part. This is some of that Mohawk epoxy putty. I used to struggle making epoxy plugs. Ebony plugs or mahogany plugs, whatever it was, and I just use that epoxy putty now to fill the holes. It's perfect. And end up painting this all black anyway, so it's just less noticeable when you look at it from the side.
There's different colors in the epoxy too?
Every wood color you can imagine. Everything from, and they have black, white, and then every wood color. Maple, cherry, natural cherry, mahogany, walnut, oak, light oak. There's a bajillion of them. And it's a wonderful I've used it for so much. Dropped a fingerboard, knocked a little chip off the edge. Took that black epoxy putty, put it on there, sanded it down. Sometimes it's, so if you put finish on it, it blends pretty well, but if it's something like a fingerboard, there's not gonna be any finish on, I'll take a super permanent Sharpie, which is for some reason is much blacker than a regular Sharpie. Regular Sharpie kind of has a blue tinge to it, but the super permanent one is real black. And just color over it and maybe take a little alcohol or something and rub it. It just disappears, man. That stuff is amazing. Then, what are we going to use to raise and lower the neck? Well, we're going to use a 1/4 inch furniture bolt that's going to go in that barrel nut, come up from underneath. And unfortunately, most all these, even real short ones you can find, they have this unthreaded neck on them, so you have to take a die and cut some threads up the, so you end up having to cut it off, because if you want it, you don't want it tightening down and driving your fingerboard up off or cracking your fingerboard from underneath. So it needs to be short enough that when it's tightened down as much as it can, it's still below the bottom of the fingerboard. So it ends up looking something like this. And goes in that barrel bolt. And at this point, if you want a heel, I'll put my heel on here before I cut everything else. Where'd that go? Oh. You know, this is what it looks like from the outside for some reason. I don't know why that's right there. But okay, so here's the neck put onto the guitar without a top on it. And you got number 10 bolts holding it into those threaded inserts, and below this hole is where the barrel furniture bolt and the barrel nut, through the barrel nut, is coming up. Now to install that tuner, the tuner drives the furniture bolt. And I had to find this out through a lot of trial and error, mostly error, how to get that in there. Because the guy that had the idea of doing the tuner, which was a great idea, he then took it a whole nother way, and it didn't make any sense to me. So this is why I ended up doing it. So I take a 3/4 inch Forstner bit and drill down, and then I drill down about 40 thousandths, which happens to 400 thousandths, 0.4 inches, which happens to be just the thickness of that bit. I don't know if they're all like that. I bet they're all pretty close. It doesn't have to be exact, but you'll see in a minute. So then I drill a small hole, because when I'm drilling, I still have, from that big hole, I had that little center from the Forstner bit that I can center the smaller bit on. If you drill the small one first, you got nothing left to center your big one on. Yeah, and it looks like that. And I'm a dummy, for a long time, man, I measured distances, from like here, from the center of this hole over, drilling through out to the front of the guitar, and trying to get it just right, And then I thought, what an idiot! I've got my tuner apart. I've got a built-in drill guide here. So I just went and bolted the body of the tuner there, and used that as a drill guide out through the front, and it worked great. Need a long bit, of course, to get under there. And then I take a step-up bit. You have to enlarge the hole to get the tuner in. And I wobble it out some more. Now, so that we've completed what we're going to do to the block. We completed what we're going to do to the neck. Now, what are we going to do to the tuner to make it work? And we're going to disassemble the tuner. And we're going to take that tuner shaft. This one already has them cut on there, but we're going to cut threads. The part of that is squared off. All right, so I'll try to line this up pretty quickly. If anybody wants to stay, I'll stay as long as you want. Anyway, we end up with that. And then take a piece of aluminum tubing, drill it out, tap it, and put the tuner together, and it's disassembled. It's not screwed in anymore, but I set that middle shaft in there and mark right here where it is, because I want to cut it off right there. I want to be sure that middle shaft doesn't stick up above the outside of the nut that's holding the tuner on. Now, it looks like that after you get it cut off. It's already got a hole in it, right in the center, which is really good, because it's real easy to take smaller bits and gradually enlarge that hole. And I end up with, I think, about a 170 thousandths bit, and then I can drive a 4mm wrench into that. Cut that wrench off 3/16 of an inch, and I want it to stick up into the furniture bolt, but I want this part of the furniture bolt bearing all the weight. I don't want it pushing down on the tuner. So I checked that, and I may have to pull that tuner out, and I may have to grind that down just a hair, whatever. So, and then I set a bronze bearing on there. I test the depth with the bronze bearing in there. Clean everything up with naphtha, and then use
Loctite.
Yeah, Loctite to put this screw in, and this shaft that I've tapped onto there. End up with something that looks like that. Put it in, and so it looks from the inside, looks from the outside. This is kind of old, but this is how I used to use the epoxy plug, but no more. I got my Mohawk epoxy. I can make it look, you can look at this one and see cosmetic. That lower plate, we don't have time, I'm sorry, to run through. I've got a little PowerPoint. I'll send it, whoever wants them, the PowerPoint that shows how to actually adjust the action. You have to loosen one of those bolts on the top, the one with the plate over it. Loosen this bolt. That's just held on with a magnet. Pull it off, loosen it, because that's just a lockdown bolt. And then go to the front of the guitar, insert 4mm wrench, and with that 600 and something to 1 mechanical advantage, every full 360 you turn on that wrench changes the action less than 3/1000ths of an inch. So you've really got a fine adjustment. Lock it down again, put the plate back in. It takes literally 30 seconds to adjust the action. And everything's locked down. The player can't screw it up. It might be 18.